Here's a puzzle. You type the string Anna divided by the string Bob, hit enter. Python explodes with an error. It's not being difficult, it's enforcing one rule. Every object has a type, and that type controls what you can do with it. Programming in Python means creating and manipulating objects. Every single value you make, a number, a word, a flag, a nothing, is an object, and every object wears a tag called its type. That tag tells Python what operations are legal. The number 30 is an integer. You can add it, subtract it, multiply, divide, raise to a power. The string Anna is a string. You can measure its length, grab a character by index, but dividing it makes no sense. Hence the error. Python has 4 scalar types, meaning atomic, single-value types. First, int whole numbers like 5, 0, negative 100, infinitely many possible values. Second, float numbers with a decimal point like 3.14, 2.0, negative 3.27, also infinite. Third, bool, short for boolean, which holds exactly 2 possible values, true or false. That's it. 2. Fourth, NoneType, which holds exactly 1 value, none, representing the absence of a value, 1 possible value ever. Memorize these 4. They are the building blocks every more complex Python value is eventually made from. To check any object's type, use the type function. Type of 7 returns class int. Type of 0.0 returns class float. Type of 9.0 also returns float. Pause on that one. 9 and 9.0 look almost identical, but to Python they are different types. The decimal point alone is a type declaration. It tells Python, treat this as a float, not an integer. This matters because operations behave differently. Integer division and float division can give different results. Make type your debugging flashlight whenever something feels off. Now capitalization. Python is strict. True with a capital T is the boolean. Lowercase true is not a Python keyword. It's just a name Python has never heard of. Type of lowercase true raises a name error. Name true is not defined. Your code editor gives you a visual clue, so the real true lights up in color, blue or purple, because the editor recognizes it as a keyword. Lowercase true stays plain black. If the color doesn't appear, you typed it wrong. Now the next question. Can we change a type? Yes, through typecasting. Casting means explicitly converting a value from one type to another using a function named after the target type. Int of something tries to make it an integer. Float of something makes it a float. Bool makes it a boolean. Here's the critical part. Casting does not mutate the original object. Float of 3 does not change 3 into 3.0. It creates a brand new object, 3.0, somewhere else in memory. The original 3 sits untouched. Here is the trap that bites every beginner. What does int of 5.9 return? Most people guess 6. Wrong, it returns 5. The int function does not round. It truncates, meaning it chops off everything after the decimal point. 5.9 becomes 5. 5.1 also becomes 5. Negative 5.9 becomes negative 5. If you actually want rounding, use the round function. Round of 5.9 returns 6 because 5.9 is closer to 6 than to 5. So remember, int chops. Round rounds, picture a number line between 5 and 6 with 5.9 marked. Int yanks it left to 5, round nudges it right to 6. Why does this matter? Imagine a financial system computing transaction fees. If you write int of the fee instead of round, every fraction of a cent silently disappears. Across millions of transactions, that's real money lost. Now let's read a nested expression. Type of float of round of 7.2. Python evaluates from the inside out. Step 1, round of 7.2 returns 7, an integer. Step 2, float of 7 returns 7.0, a float. Step 3, type of 7.0 returns float, so the final value is 7.0 and its type is float. Always unwrap nested calls inside first. Let's zoom out. Why do types exist at all? Underneath everything, your computer stores bits, just ones and zeros. The exact same pattern of bits could represent an integer, a float, a character, even a Boolean flag. The type is Python's way of saying, here is how to interpret these bits, and here is what operations are valid on them. Without types, the bits are meaningless. With types, they become numbers you can add, words you can search, flags you can branch on. This rule never changes. Later, you'll meet compound types like lists, dictionaries, and your own custom classes. Each one carries the same kind of tag, and that tag still answers the same question. What can I legally do with this? Let's lock in the takeaways. 1. Every Python object has a type, and the type controls which operations are legal. 2. The 4 scalar types are int, float, bool, and NoneType. Bool has exactly 2 values, NoneType has exactly 1. 3. The decimal point alone makes a number a float. 9 and 9.0 are different types. 4. Python is case sensitive. True works, lowercase, true crashes. 5. Casting with int, float, or bools creates a new object. The original is never modified. 6, and the most important one. Int truncates, it does not round. Use round when you actually want rounding. Whenever Python complains, the first question to ask is, what types am I actually working with? Use the type function liberally. It's your debugging flashlight, and it will save you hours every time something behaves in a way you didn't expect.